x, y, z is equal to constant, that's also in standard form. So if it's not in standard form, you will put in standard form. But in this case, it is already in standard form. So what you're going to do is you're going to make an augmented matrix. It is known as augmented matrix. Augmented matrix. You call it augmented matrix. This equal to will change into a line. This equal to sign will change into a line. Now we're going to write the coefficients of the variables one by one. Okay, the coefficient of x here is 3. So I'm going to write 3 first here. Let's see the coefficient of y. If there is no number, there is 1 there. So I'm going to write 1. Then coefficient of z is 2. And then the constant on the other side is 31. Similarly, for the second equation, coefficient of x is 1. Coefficient of y is 1. Coefficient of z is 2. And the constant is 19. Similarly, for the third one, the coefficient of x is 1, the coefficient of y is 3, the coefficient of z is 2, and then the constant is 25. This is known as augmented matrix. This is known as augmented matrix. Let's do one more example. You should know how to write the augmented matrix. Let's see one more example. So you have x plus 2y plus 5z is equal to negative 19. Then you add y minus 3z is equal to 9. And then you have z is equal to 4. You're given this equation. I say these are the 3 equations in 3 variables. You're like, this is not in 3 variables. You'll be like, this is not in 3 variables. So how you're going to do it is, this case is, okay, this one, let's see the first equation. X, y, z is equal to constant. Let's see, just a second. Give me a second. Yes. Okay. So you have first x, y, z is equal to constant. So my first equation is already in standard form. Second equation, it's supposed to be in standard form. X, y, z is equal to constant. I have y and z, but I don't have the x term. So I will add an x term myself, 0x. If x term was missing, you add yourself x term. 0 times that term, whichever is missing. Let's see in third case. In third case, my x is also missing, my y is also missing. And then the z was already there. Is equal to constant.
I just want to let you know, Bruce, his computer stopped updating, so he should be on soon.
Okay.
I'm here.
Yeah.
I'm here.
Okay.
My computer.
Okay, perfect.
Thank you.
Yeah.
When for instance, like the last one where it was just z equals 4 and you had to add the 0x and the 0y, is it always going to be like plus z, or is it ever going to be like minus z?
It could be minus z. If it was minus z, you still add 0x, 0y.
Okay, so it doesn't matter what sign you put in front of the
Z?
The z, yeah.
The z, already whatever sign is in front in initial question, that is,
Oh,
if nothing
okay,
is, it is
okay,
always
okay.
positive.
Okay.
If negative, they will write negative, otherwise it's always positive.
Okay.
Yeah.
Thank you.
So now let's write the augmented matrix. Again, make this table a line in the middle for equal to sign. Let's see the first one. The coefficient of x, 1. Coefficient of y, 2. Coefficient of z, 5. And then constant, negative 19. Similarly for x, second equation, 0. Y is 1, z is negative 3, and then 9. And then 0, 0, 1, 4. That's how you write the augmented matrix. Anyone has any question how to write the augmented matrix? If the terms are missing, 0 times that term you add yourself. I'll do more problems on this. Let's see. So let's see. You're given 3 equations as 2y minus z is equal to 7. They're given x plus 2y plus z is equal to 17. Then you're given 2x minus 3y plus 2z is equal to negative 1. These are the three equations given to you. Eric Matthew?
Yes.
Okay, let's type, I want you to write this in standard form. Is my first one in standard form?
Yes, it is. You just need to add x to it.
So if I add, what do I add?
Plus 0x.
0x. Perfect. What about second one, standard form?
Yes, it is in standard form.
Third?
Yes, one. Yes, it is.
Okay, let's see. Let forms the augmented matrix. So what will be my first term?
For the first term, you're going to have 0, 2, and then 1, and also a 7 at the end.
Okay, wait. What I'm going to write here?
0, 2, 1, 7. Yes.
Not 1, negative 1. There's a negative sign, right?
Wait, in front of the 7?
In front of the z. See, in front of the z.
Oh, okay. Sorry. I didn't realize that.
Yeah.
Okay.
What about the second one?
And then for the second one, you're going to have 1 for the x, and then 2 for the y, 1 for z, and then 17.
Perfect.
And then for the last one, you're going to have 2x, and then minus 3, and as well as plus 2, and then a negative 1.
Perfect. Eric. Any questions, anyone? Okay, I'm going to write here this example. Try it yourself. Try to find the augmented matrix for this one. 2y is equal to 2. 2x plus 3y plus z is equal to 11. Y minus 4z is equal to negative 7. Find the augmented matrix for this one.
I just crashed and came back in.
Mm-hmm. I want everyone's video on, please.
Professor, I'm supposed to be getting a whole new computer in the next couple days, so my video actually won't work still today, but I will definitely have it next time.
Okay.
Thank you.
Sure, no problem. Everyone else, I want your videos on.
Professor, I don't think my video works.
Okay, who's it?
Jesus.
Okay. But make sure for
Do you have a thing on your computer? Do you have a thing on your camera lens on your computer?
I don't.
Let me see here. Christina, it's
Are we gonna do an example when the equation's not in standard form? Because when it's not in standard,
we're gonna do a lot of problems on matrices. Don't worry, you will get all those kind of problems. Yes.
Okay, cool. Because that's when I get the most confused is when it's not in standard form and I have to put it in standard form.
Okay.
So if we can touch on that, that would be great.
Sure. Carlos. Is Carlos here?
Yes.
Okay, Carlos, can you give me what's my first term here?
Oh, sorry. Let me.
What will my first term here?
Your first term?
Yeah.
Isn't it 2?
What's the coefficient of x?
Oh, negative 2.
Coefficient of x. What's the number in front of x?
Oh, 1.
Okay, then y.
It's negative 2.
Then z.
It's 1.
Z is not there, right? So you add 0z yourself. So it becomes 0. And then what's the constant?
2.
Okay, next line. What's the coefficient of x?
2.
Y.
3.
Z.
1.
Constant.
That's 11, right?
Yes. What about x?
Y is 0.
Okay. Y,
1.
Z,
The 4, right? Negative 4.
negative 4, and constant.
Negative 7.
Perfect. That's the augmented matrix you will get from these equations. Now I want you to make a note here is matrices row operations. Matrices row operations. So what you're gonna do is, okay, first you're gonna write is 2 rows of a matrix may be interchanged. 2 rows of a matrix can be interchanged. This is same as interchanging 2 equations in linear system. So basically what they are saying is you can put this whole thing, this whole row at the second position, this second one at the first position. You can interchange. It does not matter which one I'm writing first. It does not matter. It's not like, oh, this one is written first, so I have to write it on the top. No, it does not mean that. I can interchange them. I can write it, if I write it like this, if I make again a matrix and I write 2, 3, 1, 11. First I write the second one, then I write the third one, 0, 1, negative 4, 7. Then I write the first one. It's technically the same thing. It's technically the same thing. I can interchange. It does not matter till the time I'm writing first the x, then the y, then the z is equal to constant, and I'm interchanging them, the rows. This is my row 1, this is my row 2, this is my row 3, this row 1, row 2, row 3. I can interchange my rows, and the symbol for that is row I you are changing with row j. This is the sign. When you use this sign, that means you're interchanging row I and row j. So whatever is in row I, pick that whole thing, put it at the row j position, and whatever is at row j, pick that up and put it in the row I position. Okay. Second thing you can do is the element in any row may be multiplied by a non-zero number. The elements in any row may be multiplied by non-zero number. This is same as,
Can you move it up just a little bit?
yeah, sure, I did not realize.
Thank you.
Thank you so much. Yeah. This is same as multiplying both sides of the equation by a non-zero number. So what they are saying in this one is, they are saying you can multiply the whole row with any number you want except 0. You cannot multiply the whole row with 0, but you can multiply with any number you want. I say multiply this whole row with 2. Multiply this whole row with 2. So you will get what? 2, negative 4, 0, 4. It's still gonna be the same. It's still gonna be the same thing. So you can multiply the whole row with whatever number you want except 0. And you basically write it as, so whichever row is changing, suppose my row I is changing to what? Changing what? You're multiplying with some number k your row I. That's how you write. K is any number except 0. So k is not equal to 0, and you can multiply.
Professor?
Yeah.
Oh, I'm sorry to interrupt you, but when you say row I and row J so like what rows exactly are you talking about?
Any
when it
row.
comes to the-
I and j can be any. It could be 1, 2, 3. I and j could be any 1, 2, or 3.
Okay, cool. Sounds good.
ij is just number. So here I have 3 rows. It could be any of the 3 rows.
Okay, cool.
Yeah.
Thank you.
And k could be any number other than 0. Make sure you write these matrices operations. It's not in your book. It's not written in your book. They just directly explain it. I'm going in detail, so make sure you write all this, what I'm writing here. Okay. And the third and the last operation you can do it is, third and the last one operation you can do it is, the elements in any row may be multiplied, elements in any row may be multiplied by a non-zero number, and these product may be added to the corresponding elements in any other row. This is same as multiplying both sides of an equation by a non-zero number and then adding equations to eliminate a variable. I'll explain what does this mean. Is what they are trying to say is, suppose I want my row j to change. Some row is changing. They say, what are they saying? In row j, you can add any row you want. Any row you want, you can add. And also, the row you are adding, you can multiply that row with any constant you want except 0. So what they are trying to say is, so you can multiply any row with any constant, that we know. And you can add in any row you want. Whatever you did this, you can add in any row you want. So these are the 3 operations that you can do. These are the 3 operations you can do. Example, we are going to take examples on this. Let's take examples. So you,
Professor?
Yeah.
Can we add without multiplying as well?
Yes, because that means you are multiplying with 1.
Okay.
Yeah. Suppose, so you have a matrix here. Let's see, you will get idea what we are doing. But let's given this matrix here, 21, and then you're given 1, 2, negative 3, 5, negative 2, negative 3, 4, negative 6. Okay. These are the few operations they want you to do. They want you to change R1, R2, A. Then you want to do 1/3 of R1. Okay. And then C part, they want you to twice of row 2 plus row 3. That's what they want you to do. Okay. Let's see here. Let's do one by one. Okay. Kenya? Not here. Chanthon?
Hello, can you hear me?
Yeah, I can hear you, Chanthon. So I need to interchange my row 1. Let's do the A part. Interchange rows. I want to interchange my rows. What does it become? Can you tell me?
For A,
Yeah.
we're doing A, right?
Yeah.
Okay, so you want to interchange row 1 to row 2?
Yes.
That's what it's asking? Okay. So then row 1 would be, well, then row 2 would become then row 1?
Yes, exactly.
Is that how it works? Okay. So then it would be 1, 2, negative 3, and 5.
Okay, what about row 2?
And then it would be 3, 8, negative 12, and 21.
Okay, and what about row 3? What about row 3?
And was that, sorry?
What about row 3?
It'll stay the same,
Yeah,
correct?
it will stay the same.
So it'll be negative 2, negative 3, 4, and negative 6.
Perfect. So when they say interchange, basically you will pick up this row 2, put it at the row 1 position, and row 1 position at the row 2. That's what they mean. Any doubt with this step here, A part? Everyone got the A part? Okay, let's do the B part. Now this is my new matrix. What they want you to do is, they want you to find 1/3 of row 1. So B part they want you to do is, they want you to find row 3 of R1. Okay. Can I have Anthony? Anthony? Not here? Okay. Joshua Hernandez. Maria?
Anthony said his mic broke.
Okay. Maria?
Yes.
Okay. So Maria, let's see this one. I want 1/3 of row 1. Since I'm just talking about row 1, my second and third row is gonna still remain the same. I'm not gonna touch my second and row third. Okay. Let's see my first one. 1/3 of row 1. Okay. What is 1/3 of row 1? You tell me.
I think it's, I don't know. Would I divide 1 by 1?
So multiply 1/3 with each and every term of row 1. What is 1/3 times 1?
1/3, I believe.
Yes, 1/3. And what is 1/3 times 2?
2/3.
2/3. Okay. 1/3 times -3.
-3/3.
Which is -3/3, which is
1. -1.
-1. You can simplify that. Okay. What about the next one? 1/3 divided by 5.
5/3.
5/3. So that's what you get. Okay. Any doubt with this one? So basically your new matrix, what you get is 1/3, 2/3, -1, 5/3, 3, 8, -12, 21, -2, -3, 4, -6. C part. The C part they ask you is in 2 of R2 add in, and then add in R3. Multiply your second row with 2, and then they want you to add with R3. Let's see here. Note, in this case, note your R3 is changing. R3 you're changing, not your R2. Only your R3 is changing. You're just multiplying your row 2 with a number and you're adding in R3. So my first row remains as it is. I'm not going to touch my first row. Okay. Yasmin?
Yes.
Okay, Yasmin. Can you tell me, okay, let's see. In this case, my R3 is changing, right? So my R2 will also remain the same. I'm not going to touch my R2. But what I want to do is, I want to multiply my row 2 with 2 here, and then I'm going to add in 3. Let's see. So when you multiply, what is 3 times 2?
6.
And what is 6 minus 2?
3.
6 minus
6
2?
minus 2, 4.
4. Perfect. Okay. In next term is 8 of R2, right? You multiply 8 with 2. What do you get?
16.
And what is 16 minus 3?
13.
Okay, can you tell me what will be my next, what I'm going to do for the next term?
Negative 12, right?
Yeah, negative 12. What are you going to do with negative 12?
Multiply it by 2.
Yes, you're going to multiply by 2. It becomes?
Give me a second. Negative 24.
Negative 24, and then what you're going to
do? Subtract it.
Add 4, add 4, add 4.
Add 3, yeah.
Add 4.
4,
yeah,
okay.
Because 4 is there, right? At the bottom of that number, negative 12?
Yeah.
So you're going to add 4. Let's see. Next one, 21 times 2 is?
21 times 2 is 42.
And then minus 6 is?
36.
36. That's how you do it. Good. So this is how you're gonna do it. Make sure you have your calculators next to you. This topic specifically needs a lot of calculation. So you should have your calculator next to you, where you can multiply and add directly and figure out your answer. Any
Professor, I have a question. Yeah. Should that be 20 or negative 20?
It's going to be negative 20. You're correct. It's going to be negative 20. Thank you, Caesar. Yeah. Any questions, anyone? Okay. So I will give you, let's see here. Okay. So you are given a matrix. You are given a matrix 4, 12, negative 20 and 8. 1, 6, negative 3 and 7, negative 3, negative 2, 1, negative 19. This is your matrix. I want you to do 3 operations. Change row 1 and row 2, 1/4 of row 1, and see you're going to change your row 3 to row 3 plus 3 times row 2. These are the 3 operations I want you to do right now. Try it yourself first. Reese, is Reese here? No, Reese is not here. Joshua, Ramirez?
Yeah.
Okay. So can you tell me the first one?
So put the box. You do 1, 6, negative 3, and 7.
Okay.
And under that one, you would put 4, 12, negative 20, and 8.
Okay. Third one.
And then you would put negative 3, negative 2, 1, and negative 9.
Perfect. Niza.
Yes.
Okay. So next part you are gonna do is, well, you want 1/4 of R1. So you're basically multiplying your row 1 with 1/4, and this is your new matrix. Okay, yeah.
Okay, so we'll start off with 1/4.
Okay.
Then 3/2.
Okay, perfect. Which is 6/4, 3/2. Perfect.
Negative 3/4.
Perfect.
And 7/4.
Perfect. And what about
And
the
then
one?
the other 2 rows are the same.
Perfect. Anyone has any doubts in the first 2 parts? and the C part here. Is that already? Can I have Fernando?
Yeah.
Okay, Fernando, for the C part, what you want to do is, my row 3 is changing, right? My first 2 rows will remain as it is, 1 by 2, 3 by 2, negative 3 by 4, 7 by 4, 4, 12, negative 20 and 8. Okay. What I want to do is R3 is changing to R3 plus 3 times R2, right? So my row 3 is changing. In the previous one, what they want you to do is, they want you to multiply with row 2 the 3 and then add to R3. Do it.
Wait. So you said multiply the row by 3?
Row 2 by 3
and then
add to R3. So how you do it is, multiply this 3 with the first term. 3 times 4 is?
Yeah, so 12, for example?
Yeah, 12, and subtract, add this bottom one. What is 12 plus minus 3?
9.
9. Perfect. Similarly, do the
Okay.
second term. What do you get?
So 12 times 3 is 36. Subtract 2, 34.
Perfect. What about the next term?
So negative 60 plus 1, so negative 59.
Perfect. How about next one?
Positive 24 minus 9.
Which is?
Is it 15?
Yeah. Anyone who did not see one, C part is very important. Make sure you understand how you got it. So you write like this. If it's 3 times R2, just write it like this and then just add. You're not directly multiplying R2 with 3. It's just the operation you are doing like that. Your first 2 will still remain the same. Any questions so far? Anyone?
Professor.
Yeah.
Okay, for step B, before we go more forward, how did you get 3 over 2?
3 over 2. So, okay. What is 6? So, you get 6 divided by 4, right?
Mm-hmm.
So, she made factors of 6, which is 2 times 3. And then 4 is 2 times
2.
And 2 got cancelled, so you're left with 3 over 2.
Oh, okay.
Okay, yeah.
Thank you.
Yeah. Anyone has any other questions? No?
I have a question.
Yeah.
I got 15 on the bottom for the first one. How did you get 9?
The first one?
No, like for C, the bottom row, the first number of the bottom row, the 9 for C.
You got the rest 15.
Yeah, because maybe I did it wrong. I'm just not sure.
See here, Kat. You have to multiply 4 by 3, right?
Mm-hmm.
Which is 12.
Oh.
And then in 12, basically it's minus 3, you subtract 3. What is 12 minus 3?
Oh, it's a negative. That's okay.
Yeah, you accidentally forgot the minus sign.
Mm-hmm.
Yeah. Any other question, anyone?
I do have a question. Something similar to Kat was saying is, if there is no negative sign, do you still subtract it, correct?
No, you add.
Oh, add it? Okay,
if
cool.
There is minus
okay,
sign, you subtract, yes.
Okay, cool.
Yeah. Any other question, anyone? Okay. So next we're gonna go to the main topic now. So main topic is, you will be given 3 equations. The question will say, use matrices to solve the system. You have to use matrices to solve the system. Note, you know 3 things. You know 3 things about matrices. You can interchange rows. You can multiply a row with anyone. Or what you can do is, third thing you can do is, you can multiply any row with some number and add to that row. So these are the 3 operations you can do. I again repeat. You can interchange rows. You can multiply a row with any number you want. And you can multiply a row with a number and add to a next row. It's up to you which one you want to do. So now we have to solve. You will be given equations like 3x plus y plus z 2z is equal to 31. And then you're given x plus y plus 2z is equal to 19. And x plus 3y plus 2z is equal to 25. Okay, yes. You're given this equation. Let's solve this. Let's solve this. How you're going to solve is, first make sure standard form, augmented matrix, write the augmented matrix. Jesus.
Hello? Yes.
Yeah, I can hear you. Yeah. So let's see. I want to write the augmented matrix for this one.
Okay.
So can you tell me what's augmented matrix?
Yes, so the first one's going to be 3, 1, 2, and then 31.
Okay.
The second one's going to be 1, 1, 2, 19. And then the third one's going to be 1, 3, and 2, and then 25.
So this is your augmented matrix, correct? If some term is missing, x term is missing, you replace that with 0. We did that already. You wrote the augmented matrix. Perfect. So this is your step 1 to write the augmented matrix. Step 2. In step 2, what you want to do is, you have to make this term here, the first term, the very first term, make this term as 1. Make this term as 1. I need to make that term as 1. Anyone can suggest me, out of the 3 operations you learned, interchanging rows, okay, multiplying that row with some number, or multiplying a row with some number and adding to that row, out of those 3 operations, what can I do to make this as 1?
Interchange.
Yes, if I interchange with row 2 or row 3, it's up to me. Both have 1 here. If I interchange, my first term will become 1. So what I'm doing is, I think I should interchange with 2. I'm gonna write this step here. You have to write this step here. That means you're interchanging row 1 and row 2. So my row 2 becomes my row 1, and this becomes my second row, and third remains as it is. Your next step is to make this 0. Okay, anyone can suggest me how to make this 0? And make sure I cannot touch this one. This cannot change. Whatever I made right now, I made this as 1, right? I cannot touch this. This has to remain constant. But I need to make this as 0. Anyone who can tell me how to make this as 0?
You multiply row 3 by -3?
Yes, and then add to that thing, right? I can do that. Perfect. I cannot interchange rows. That will not make it 0. Okay. And one thing to always remember, always interchange with the lower rows. So if you're talking about row 2, now always interchange with the lower rows. Don't interchange with the top rows, because then you're going to change what you made right now. Okay. So in this case, I don't want to interchange. That will not work. Okay. If I multiply something, it won't work. So what I can do is, my row 2 is changing, right? In row 2, she said add row 3. But what if I multiply my row 3 with -3, the opposite number? Because the opposite of 3 is -3, that will make it 0. Perfect. Let's see what it becomes. Lauren?
Yes.
Okay. So my first row will remain as it is. What will be my second row? You tell me. So I'm doing this operation now.
And you want to make 3 0.
Yes.
So you're going to be.
So you multiply this with
going to
this thing
add-
and add here. What do you get? What is 1 times -3?
1 times -3 is going to be -3,
And
and then -3. plus 3 is 0.
Okay. What about the next one?
1 times 3 is going to be 3.
No. You're multiplying with the third row.
Oh.
Yeah.
Sorry. So 3 times negative 3
Yeah.
is going to be negative 9.
Plus 1.
Plus 1 is going to be negative 8.
Perfect. What about next one? Let's see.
Negative 3 times 2 is going to be negative 6. Plus positive 2 is going to be negative 4.
Yes. Perfect. What about next one?
Negative 3 times 25 is going to be negative 75.
Mm-hmm. And then you're adding?
Oh, and then I'm adding 3.
Adding 31.
78.
What do you get?
Oh.
There's 31 here, right? So you're going to add 31.
Is negative 44.
Negative 44. Everything else remains as it is. Any doubt so far?
I have a question.
Yeah.
So why would you times negative 3 by the third row? Because you're trying to get it for the second row, correct?
Yeah, I need to make this as 0. This term as 0. To make this
Right.
0, I need negative 3, right?
Yeah.
I don't have negative 3 here. I don't have negative 3 here. Even if I multiply this row with something, I'll still not get negative 3. Right? So what I did is I multiplied this row with negative 3 and I added to this one. You can do it the other way also. You can multiply this row also with negative 3. Because if you multiply this row also with negative 3, this will become negative 3, right?
Mm-hmm.
And then you can add to this row.
Okay.
You'll get it, Chantan, you'll get it once we do more problems, you'll get it. It's just too much, yeah. Next thing I want you to do is next step. So this is always this step. So we made this as 1, that's my first step. Then I made this as 0, that's my second step. Now my third step is to make this as 0. Make this as 0. You are like, oh, I will interchange the rows now. I will interchange the rows and this will become 0. No, you cannot do that. You don't have to touch these two. These two cannot change, because if you interchange, this will become 1. And I don't want that. I just made it 0. I don't want to touch this. So I have to use something else other than interchanging now. Other than interchanging, I need to use something else. Anyone who can suggest me what to do with now?
Multiply first row by -1.
Exactly. So my row 3 is changing because I want my this row, this to become 0, right? So that means my row 3 is changing. And he is saying use row 1 and multiply the row 1 with -1. The opposite of that number. So it's 1, I'm going to multiply with -1. Here it was 3, so I'm multiplying with -3. So multiply with -1. So he's saying multiply this with -1 and add to row 3. Let's see. Richie is not here. Jordan Paulo. Jordan.
Which Jordan?
It's Paulo. He's not here.
That's on me.
Cat.
Here.
Okay. So Cat, can you tell me what happens? What will be my first row will remain as it is, right? I'm not touching my first row. I'm not touching my second one. The only thing I'm trying to change is my third one. So what does my third one become?
You would do, for the first one, you would do R3 equals R3 plus -1 times R1, which would be 1 plus -1 times 1, which would equal -1 for the first one.
Mm-hmm.
And then the second one would be...
Hey, see here. So you are multiplying -1 here, Kat. Can you see the screen?
Yeah.
Yes. So what you're doing is you're multiplying the row 1 with -1. So I write here -1, okay? I write in front of row 1 as -1 because I'm going to multiply it with -1, okay? And then I'm going to add it to R3. Let's see. What is 1 times -1?
-1.
And -1 plus 1 is?
0.
Okay, so this first term will become 0. Okay. Let's do the second term. Multiply, what do you get?
-1 again.
And what are you going to add?
+3.
Yes, so what do you get?
2.
Okay. What about the next one?
-1 times 2 is -2 plus 2 is 0.
Okay. What about next one?
-19 plus 25 would be 6.
Okay, perfect. Any doubt till this step here? So I made this as 1, that's my first step. Then made this as 0, perfect. My third step was always to make this as 0, perfect. You know what's your next step? Next step you want to make this one, the next diagonal element. So this was one diagonal, this was second diagonal. This term, make this 1. So diagonal elements you are making 1 and everything underneath that as 0. Let's see. Okay, so anyone can tell me how can I make this 1? Anyone?
Is it pointing at the number 8?
Yeah, -8.
At the negative?
Yes, I made to this one.
You could multiply the bottom row by 4, the third row, or do we have to multiply the top row?
See, if I multiply by 4, what does it become?
The 2 would become 8, so it would just take it out.
And it will become 0, right?
Yeah, 0. So
I don't want 0, I want 1.
A 7, or I mean a 9 instead to make it positive.
Okay, so what you can do is, I would suggest to make 1, okay, just a trick thing I would suggest is to make something 1. So we are making this 1, we are making this 1. To make something 1, I would suggest you either interchange with lower rows or divide the whole row with that number. So that's what I say. It's like these are the two things you can do. Either I would say the best thing to make something as 1. I needed to make this 1, you interchanged, perfect. But here I cannot interchange. You're like, I can interchange with the top one. No, you cannot interchange. The reason you cannot interchange is because it will change this order. I don't want this thing to change. This should remain as it is. You can always just interchange with the lower rows. This is a trick part you can remember. You can interchange with the lower rows or divide the whole row with that number. So what I'm going to do is row 2, I'm going to divide the row 2 with -8. Whatever number was there. Whatever number I want to get rid of, I divide the whole row with that number. So what does it become? 1, 1, 2, 19. Okay, divide. So I'm dividing this thing. So basically I'm multiplying by -8, or you can say dividing by -8. 0 divided by -8 is 0. -8 divided by -8 is 1. And then you have -4 divided by -8. Let's see what you get. -4 divided by -8. Negative makes it positive. So you get 4 over 8. And factors of 4 is 2 times 2 and 8 is 2 times 2 times 2. People who don't know how to do the factorization. 1, 2 gets cancelled, 2 gets cancelled. You're left, nothing is left on the top. 1 is left on the top. So you get 1 over 2. Then you have 44 divided by 8. Negative makes it positive. So it's 44 divided by 8. 2 times 22 and times this, and then you have 2 times 2 times 2. When you cancel, you are left with 11 over 2, and the last row remains as it is. Any questions?
So for this particular problem you just did, you just multiplied the second row with the negative divided by -8 in order to get the -8 to be a 1. Is that correct?
Yes. Yes.
Okay. Sorry, I guess I was confused from the last problem because we've multiplied the third row and not the second row.
Oh, you can multiply any row you want. It's up to
Okay.
you. It's just the steps are this. So first step is to make this one and make these 2 zeros. Then you have to make this one. And if you cannot make it 1 using the initial steps of interchanging and all, just divide the whole row with that number. It will give you 1.
Okay.
So now your next step. So you made this as 1. Okay. Then you made this as 0. Good. Then you made this as 0. That's your third step. This is your fourth step. You made this as 1. Your fifth step, make this as 0. You're going to make this as 0. So basically what you are trying to do is you're making diagonal element as 1 and then everything else underneath that as 0. Anyone can suggest me how to make this 0. So my row 3 is changing. I know my row 3 is changing. How do I make it 0? What I can do is I can multiply. Note, what if in my row 2, what should I multiply to make it 0? -2. Opposite of 2. Opposite of 2. Opposite of 2. And let's see what you get. Let's see what you get. Can I have cat already said Caesar?
Caesar.
Yeah, so my first 2 will remain as it is. I want you to tell me what will be my third one.
Okay, let me finish writing this down. 1, 1, 2.
Note you're multiplying your row 2 with second -2, right? So I'll write -2 in front of row 2, whatever row I'm multiplying. And then try to solve.
-2 to R2, right? To row 2?
Yeah.
And then you're adding it to row 3. So the first one's still going to be 0.
Mm-hmm.
And -2 and then +2 is 0.
Okay.
And then that makes -1 plus 0 is -1.
Mm-hmm.
And then -22 over 2 is -11 plus 6 is -5.
Perfect. So that was my step. First step to make this as 1, then this as 0, then this as 0, then this as 1, then this as 0. My last step is to make this as 1. Make this term as 1. Last step, the very last step, almost you are done there. Make this as 1. Anyone who can tell me how to make this as 1?
Divide by -1.
Exactly. My row 3 is changing. I can divide or multiply by -1. It's still gonna give me the same thing. Let's see what you get. So my first 2 rows will remain as it is. 1/2 11 by 2. If I multiply this with -1, -1 times 0, 0, 1, and this becomes 5. We are almost done. We are almost done with this thing. Okay. Now what I want you to do is, so you got this matrix, right? Once you reach this problem here, where you made this as 1, then this 0, then this 0, next diagonal as 1.
Would it be negative? Would it be -5 or just 5 for the third row?
Just 5, because -5 times -1 gives you 5.
All right, never mind.
Okay. And now after making that 1 0, this 0, and then this one, these are pre-designed steps. You have to do it this way only. What I want you to do is go backward, and I want you to write the equations now. I want you to write equations. Remember, this was this times x, so you get 1 times x plus 1 times y plus 2 times z is equal to 19. I'm writing the equations now backward once you're done this. In second one, 0 1, I don't have to write. I get 1 times y plus half times z is equal to 11 over 2. And from third one, I get z is equal to 5. Anyone who did not understand how I wrote these equations?
Would these be our answers?
No. So what here is, we need to find the value of x, y, and z. That was the problem. Once you got this, you know your z, right? This is known as back substitution. Put the z value in the second equation. You will get the value of y. Let's do it. So you get 1y plus half 5 is equal to 11 over 2. Which is 1y plus 5 over 2 is equal to 11 over 2. Let's see what you get. Subtract 5 over 2 both sides. You get y is equal to 11 over 2 minus 5 over 2, which is 6 over 2, which is 3. Back substitution. From the third equation, you will get the value of z. Put it in the second equation. You will get the value of y. Put the value of, so you got y is equal to 3. Put the value of y and z in the first equation, you will get the value of x. So let's see, it becomes x plus 3 plus 2 times 5 is equal to 19. You get x plus 3 plus 10 is equal to 19. You get x plus 13 is equal to 19. Subtract 13 both sides, you get x is equal to 6. So your answer is 6, 3 and 5.
Is that so 1y plus 1/2 times 5?
Yes, 1/2 times 5. Because see here. 1/2 times z, right?
Oh, okay.
And z was 5.
Oh, okay.
Yeah. And that's your final answer. You found the value of x, y, and z using matrices. I know there's too many steps in this. But once you get it, you start doing it, it will become easier for you. We're going to do one more problem on this. Don't worry, we're going to do many problems on this.
I see the bottom.
Could you move the paper down a bit?
Yeah. Just, yeah. I want everyone to start doing this problem here. Start doing this problem here. 2x plus y plus z, 2z is equal to 18. Then x minus y plus 2z is equal to 9. X plus 2y minus z is equal to 6. Do this problem right now using matrices. I want you to find the value of x, y, and z using matrices. Julian? Is Julian here? Julian Robert? Okay, absent. Dylan? Dylan Joseph? Dylan Joseph. Aswin. Rockwell.
I'm here.
Okay, Dylan. Rockwell or Dylan? Dylan Glenn. Or Dylan Glenn is there too. Okay.
I'm here.
So Rockwell. Okay, let's form the augmented matrix first. Can you tell me the augmented matrix?
I cannot. I'm not sure what the augmented matrix is. I saw it written when I came in. But
okay. So what's the coefficient? First of all, you need to write as C. It should be in standard form. X first should be X term, then the Y term, then Z term is equal to constant. Then again in the second equation also X term, then Y term, then Z term is equal to constant. X term, Y term, Z term is equal to constant. First it should be in standard form. Here it is already in standard form, right? So first you're going to write is coefficient of X. What's the coefficient of X in first equation?
2.
Y?
1.
Z?
2.
And then constant?
18.
Okay. Again, for the second one, X?
1.
Y?
Oh, what the fuck? Hold on, wait, no, my computer's messing up right now. Screen just went black.
Okay. Y?
Hold on. My screen just went black, just a moment. I can still hear you, but I can't see you.
This is blocked. So it's okay. I'm going to write here -1, 2, 9, then 1, 2, -1 and 6. That's your augmented matrix. Okay. Dylan?
Just his microphone isn't working.
Oh yeah, his microphone is not working. Okay, no problem. Okay, Gerardo?
Yeah.
Okay, Gerardo. What's my first step?
Hold on, give me a second. I gotta look back at my notes.
Mm-hmm.
Don't we have to find out like what we want to do first?
Yeah, the first thing is always to make this as 1. The first term as 1.
Oh, okay, yeah, okay, I see it then.
How
Has
do
to
you
be
make that
one,
as
so we can either interchange rows or... Oh yeah, we can do that. Yeah, let's do that.
So what are you gonna do? With which row you wanna interchange? Row 1 with which row?
Row 2.
Okay, you're changing with row 2. Perfect. What do you get? Can you tell me? What's your final answer?
You just switch it, right? So it's gonna be like the same thing as row 2. So it's gonna be 1, -1, 2, 9.
And what would be my second row?
2, 1,
perfect.
2,
Right.
18.
1, 2, -1, 6. Third remains as it is. Perfect, perfect. Okay, Jose?
Yeah.
Okay. Jose, for the next one, what's my next step?
Let me look back. Make the second row 0.
Yeah, make the second row, this term as 0 now. How do you make this row? So you're saying second row is changing, right?
Yeah.
So what I'm gonna do in
So
second
you, you would multiply the third row by -2.
Okay, yeah. We can multiply by third row or the first row, right? Because both are 1.
We can do both?
Both. It's up to you. I say row 1. Let's do row 1.
Alright.
Just for easy. Okay. So
Does it matter normally? Which one should we do normally, or you just think whichever one we want to go?
Row 1. I would always say, since you made that one, you already made that one. That was your first step, right? To make that one. You already made that one. I would say go with row 1. I mean, usually it won't matter. It will still give you the same answer, but it's suggested that go with row 1.
Alright, no problem.
So, what do you get? Can you tell me?
So your row 1 would become... Wait, do you want me to just tell you what the answer would be, or do you want me to tell you what row 1 would be?
So row 1 will remain as it is. Row 1 does not change.
It would be 0 for row 2. It would be 0. -2. That would just be -1.
No.
Yep. Negative. Oh, that's a negative times a negative. That would be 3, right?
Yes. And then?
And then 2 times negative 2 is 2 plus 2. So just negative 2.
Yes.
And then 18. And then 18, 9 times negative 2, and then 18. That would just be 0.
Okay, and third remains as it is. Perfect, perfect. Brian? Daniela? Is Daniela here? Joshua? Not here. Dylan Chatra? He's not here. Sabrina?
Here. Sorry, I was trying to get my mic on.
Yes, it's okay. So what's my next step after this, Sabrina?
You would make. What do you make 3 into 1?
No. First, that we have to do. That's after that step. 1 is to make this 0, right? So we have to make this term 0. How do I make this term 0?
By multiplying by negative 1.
Yes. Which row is changing?
The third one.
So row 3 is changing. So I'm going to write row 3 changes to row 3 plus. Which row am I multiplying with negative 1? Okay.
Is it row 3 or?
So row 3 is changing, right? You're saying in row 3 I'm adding something. Minus negative 1 times some row. Which row is that? If I multiply this row, what happens? What do you get? 0 times negative 1 as?
0.
And what is 0 plus 1?
1.
So I'm not multiplying with row 2. Because I want to make this as 0. Let's see with this one. But if I multiply this with negative 1, what happens? What is 1 times negative 1?
Negative 1.
And then negative 1 plus 1?
Two.
Negative 1 plus 1. 0. That becomes 0. So that means I'm going to multiply with row 1. Okay? Let's see. So
with row 1?
Yes, because if you multiply, see, 1 times negative 1 gives me negative 1. And then in negative 1, if you add 1, it becomes 0. That's the reason I'm multiplying with R1, not R2. Okay? So my first 2 rows remains as it is. 0, 3, negative 2, 0. Can you tell me what will be my third row?
Give me a minute. 0, 3, so it'd be negative 1 times 1.
Yeah.
And then you add
1.
Okay. Sorry, this is a little confusing.
Yeah.
So it'd be negative 1 times 1, which is negative 1 plus 1 equals 0.
Okay, what about the second term?
That would be negative 1. It'd be negative 1 times negative 1.
Yes.
Which is 1.
Then?
Plus 3.
But not plus 3.
No. Plus row, with the row 3, right?
Yeah.
Is it plus 2?
Plus?
Is it plus 2?
No, this is plus 2, right? So negative 1 times negative 1 got you 1, right? And then what is 1 plus 2?
3.
3 here. What's the next one? What is 2 times negative 1?
Negative 2.
And what is negative 2, negative 1? Negative 3. Okay.
Mm-hmm.
And what is 9 times negative 1?
9 times negative 1. Negative 9.
Negative 9. What is negative 9 plus 6?
Negative 3.
Perfect. That's it. That's what you got. So you made this as 1 and these two as 0. Okay. Can I have Jordan?
Professor, I have a quick question.
Yeah.
So on that last row, could we have just if we were doing this question on an exam or something, so we ended up doing row 3 plus negative 1 times row 1.
Yes.
Do we always have to multiply, if we're multiplying, could we have done row 3 plus negative 1 at all, or just negative 1, or did it have to be row 3 plus negative 1 times row 1? Or could we have just done the row 3 plus negative 1? And that
no, you cannot do that. You cannot add negative 1. You have to multiply a row with that.
Got it. Okay. Thank you.
Any other question? Anyone? Okay. Jordan?
Yes.
Okay. What's my next step?
So it looks like you're gonna go with we were just trying to make row 1, the third term, 0. So now we're gonna make the second term.
Yeah, the diagonal.
On the second row.
Yes.
1.
Yes, you have to make that 1. And how do I make that 1?
You're gonna be doing row 2.
Mm-hmm.
And then the arrow, do R2 and divided by 3.
Perfect. Let's see what you get in this case. So my first, this thing, and my first will remain as it is. My third will remain as it is. What does my second one become when you divide by 3?
Just 1 second, I need to write it down. Okay. The second row?
Yeah.
Yeah, so the first term is going to be 0.
Okay.
The second term is going to be 1.
Okay.
And then the third term is going to be negative 2 over 3.
Okay.
And the fourth term is going to be 0.
Okay, perfect. Okay, Haley?
Hi, yes.
Hi. So, what's my next step?
Let's see. I don't know, I'm still having extreme troubles with this one. Give me 1 sec.
See, we made this as 1, we made this as 0, we made this as 1, we made this as 1. What's our next step?
I'm just right. Don't you have to make the 3 a 0?
Yes, exactly.
Is that correct?
Yes, exactly. So my row 3 is changing. Row 3 is changing to what?
And then would you no, you wouldn't multiply it by 0, would you?
No, you cannot multiply by 0.
Yeah, I was still a little stuck on this. Can you walk me through it?
I want to see. In row 3, I want to add something. Since I cannot interchange rows, right? I cannot interchange rows because that will change this thing here. I don't want to change this thing. What I want is, in row 3, what I can do is I can add some row. And I can multiply that row with something to make it 0. Okay. To make this 0, what do I need? To make 3 as 0, what do I need? To add to 3 to make it 0?
Negative 3.
Negative 3, right? I multiply, let's check one by one. I try to multiply the second row with negative 3 and see. If I add to my third row, what happens? What is 1 times negative 3? Haley?
1 times negative 3 is 3.
And then if I add 3, what happens?
I'm sorry, it keeps cutting out. Well,
1 times negative 3 is negative 3, right?
Correct.
And in negative 3, if I add 3, what do you get?
0.
That's what I wanted here, right?
Yes.
So what I'm going to do is, I'm going to multiply by negative 3. But which row I'm going to multiply by negative 3? Second row. Because when I checked, it's giving me 0 here.
Okay.
Okay. Now let's do it. Let's see what you get. So my first row will remain as it is because that's not changing. Second row will remain as it is because that's also not changing. Only my third row is changing. Can you tell me what will be my third row?
Second row. So it would be
0 times negative 3?
It would be 0.
And 0 plus 0?
0.
Okay. 1 times
and
negative
then, are you doing like the negative 3 times a negative 3?
No. Negative. Yeah, first you do this one. 1 times negative 3.
1 times negative 3 is negative 3.
And then plus 3?
Is 0.
Okay, perfect. What about the next one? What is negative 2 over 3 times negative 3?
Negative 2 over 3. Would that be 6 over 3?
Yes, which is?
1/2?
No. What is 6 divided by 3?
6 over 3 would be
2.
Oh, okay.
Yeah. What about the next term?
And then
0 times negative 3 is?
0 times negative 3. Oh, 0.
And then plus negative 3 is negative 3.
So the last number would be negative. Oh, okay.
Yeah, good.
Okay.
Professor, I have a question.
Savannah, yeah.
For row 3, term 3, wouldn't that be negative 1? Because it's going to be negative 6 over 3, or it's going to be positive 6 over 3. That's 2, and then you add the negative 3?
No.
Of the previous term?
Oh, yes. Yeah, that's correct.
Okay.
So you're going to add 3, it's going to be negative 1. Correct. You're correct. Because you when multiply negative 2 over 3 times negative 3, it gives you positive 2, and plus negative 3 gives you negative 1. I did not add negative 3 to it. So it's negative 1. Correct. Savannah?
Yes.
What's the next step?
Let's see. We have to get that last term, the third term on the third row to 0, correct?
1.
The 1, okay.
Diagonals you are making as 1. This one, and this one you have to make 1.
Okay, let me write this down real quick. So you'll have the first 2 rows the same. So it'd be your little matrix bracket with 1, negative 1, 2, 9, 0, 1, negative 2/3, and 0. And then for the bottom row, so we want to get that negative 1 to be 1, right?
Yeah.
Okay, so let's see. We could do row 3 becomes R3 times or plus positive 1 times row 2, or no?
Let's see if you do that. You're multiplying row 2 with 1 and adding to this thing, right?
Yeah. Oh wait, it needs to be 1 though, so that wouldn't make any sense.
Yeah.
Okay. Dang.
This is not correct. So what you can do? Can you interchange rows?
I don't know.
There is no 1 above, right?
Yeah.
And I don't want to interchange rows because if I interchange, all of these will change, which I made right now.
Got it.
Okay. So can I multiply or divide with any number to make it 1?
You can multiply by 1 to get it to, wait, no. Oh my gosh, I'm so confused, I'm
You
sorry.
have negative 1. I need to make it 1. What should I multiply with it?
-1 to become 1 times -1.
Yes. So I will multiply my row 3 with -1 to make it 1.
Okay. See, so in this case, all you'd have to do is multiply that bottom row by 1. You don't have to multiply it by any other rows?
No, just the bottom row with -1. That's it.
Okay, that makes so much sense.
So it becomes 0, 0, -1, -1 makes it 1, -1 times -3 gives it 3.
Okay.
Yeah.
So once we finish basically getting all of them to the correct spots, when we're working on that last one, we don't have to really multiply it by another row. You can just, I mean, in this instance, it's just trying
always,
to...
when you're dealing with that last one, I would suggest whatever number is that here, just divide with that number. Just divide the whole row with that number. Whenever you're making 1, divide the whole row with that number or interchange with the lower rows.
Okay.
Here there is no lower row, so I cannot interchange. So I will divide whatever number is here is -1. So I'll divide the whole row with -1.
And you can do that because the rest of the row is 0, so it doesn't really affect it.
Affect it, yes.
Thank you for explaining that. That makes a lot of sense.
Okay, Martin?
I have just a quick question. Just how do you get the 1 on the one before it? I've just been confused.
This one?
How do you get -1? Because you know how it's 0, 0, -1, -3. Yeah, I just don't know how you got the -1.
Let's see it. I was multiplying this with -3. So what is -2 over 3 times -3?
My calculator gives me 2.
So it will give you what? 2, right?
Yeah.
When you multiply. And what is 2 minus 3? You have to subtract 3 also, right?
Oh, yeah. Never mind.
That's going to give you -1. Yes. Okay, Martin?
Yes?
What's my next step?
We put the general form.
Okay. What do you get?
Would be x. The first question would be x minus y plus z equals 9.
2z is equal to 9.
2z?
Yeah, because it's 2, right?
Oh, yeah.
Yeah.
Yes.
And the next one?
Then it would be y plus 9
3z is equal to 0. Okay. And the last one?
E equals 3.
Perfect, Martin. Christina? Is Christina here?
Yeah, and then you will substitute the z into the y minus 2 over 3.
Yeah.
So it'll be 6 over 3, which is 2.
With y as?
So y minus 2 equals 0, so y equals -2, or positive 2.
Positive 2. You got z and you got y. Okay. I need to find x. How do I find x, Christina?
You substitute the z and the y, so it'll be x minus 2 plus 6 equals 9.
Okay, so you get x minus 2 plus 6 is equal to 9. X plus 4 is equal to 9. We get x is equal to?
5.
5. Perfect. So your answer is 5, 2 and 3. Perfect.
I have a question.
Yeah.
You got plugged into the original formulas, it would come out the same, correct?
Yeah, if you can always check. Put these x, y and z values in the original problem. Your left hand side and right hand side should be equal. So here, that was your original problem here, right? This was your original problem. If I put x as 5 here, y as 2 and z as 3, it will come out to be equal to 18. Similarly, here also if I put x as 5, y as 2, z as 3, it will come out to be 9. Similarly in this also. So basically found the solution of the equations using matrices. Any doubt, anyone?
I have a question about the first equation. After we're finished with the matrices.
Yeah.
So is the x just kind of eliminated because it stands for 0? technically, or?
Where is it 0?
So the first one that we wrote down, x minus y plus 2z equals 9.
Yeah.
The x just kind of went missing.
Yeah, so that you don't have to write. The 0 term you don't have to write.
Okay, so how did 9 get to 0?
This one?
Oh, because you're multiplying. Never mind.
Yeah,
okay.
Okay.
I get that.
Okay.
All right, cool. Thank you.
Any other question, anyone? When this comes in exam, this problem itself will be worth 10 marks, 10 points at least. And you are getting a problem on this. So make sure you understand this. This question itself will be at least 10 marks worth if you get to solve the matrices. Any doubt or you want me to solve one more problem with you guys? Okay. So I'm gonna go to the next topic is determinants. Before that,
can we take a quick break?
I was about to give a break, yes. It's like, so I'm going to give it 10 minutes break. Let's meet at 11:15. And if you guys have any problems, stay back. And if you did not understand matrices, you can stay back. I can explain you how to do it or help you out. But let's meet at 11:15.
Professor, can I just go over with you the last part, like solving? Because I'm kind of confused on why you plugged in what you plugged in at the end to like find the x, y, and z. Yeah. So like to find z, you did x minus y plus 2z equals 9. That's obviously the first equation given, right?
See here. These are the equations I get from my matrix here directly. Okay, if I write my equations backward, what does it become? X minus y plus 2z is equal to 9, right?
Yeah.
From the second one, what do I get? I don't have to write this 0, 1. I get y minus 2 over 3z is equal to 0.
Okay.
And from the third one, I get z is equal to 3. Third one will always give me z value directly.
Okay.
Okay. Then what I'm going to do is back substitute. I'm going to substitute back in second equation, this 3.
Okay.
So I substitute here y minus 2 over 3 and z was 3, right? I put here 3. And then I solve. What is minus 2 over 3 times 3?
So you got 6 over 3, which is why you got 2.
Which is why I got 2. And I got my y minus 2 and I got y as 2.
Y minus 2 equals 0. Okay. You added with 2 to both sides?
Yes.
And then, okay.
Yeah. And then I got
and then
x
the
and
last
z.
One.
And x, I got y and z, right? Now I'm going to use these both values and put it in the first one.
Okay.
My y came out to be what? 2, right? I put here 2 in the equation.
So x minus 2. Oh, okay. X minus 2 because y equal 2.
Plus
you
2.
Added 2.
And z was?
Z was 3. So you plugged in 3 for z. 9, and then you just solve across.
Yes.
Okay. I see.
It's always back substitution.
Perfect.
From this one, when you will always get z. From this, when you plug in, you will get the value of y. When you plug in these both, you will get the value of x.
Okay. Thank you.
Yeah, perfect. Any other question, anyone? Chanthon, you got it?
Yeah, I think so. I think I'm gonna have to go back and just check my answers and put in the problem. So.
Okay.
But yeah.
Perfect.
Thank you.
Yeah.
Professor, while everyone's on break, would you mind just putting up another problem that we can work up on our own and see if we get the right answer at the end, like without you guiding us through it, just to kind of have to work on.
That would be perfect actually if you can get that. Let me give you an example. So you have, let me write it here. So you have x plus y plus z is equal to 4. Okay, wait, let me give you some other one, not this one. Let me give you one more, which is x plus 2y is equal to z minus 1. Then you have x is equal to 4 plus y minus z. And then you have x plus y minus 3z is equal to negative 2. Brian, can you give me the metrics only so that I know you got the metrics correct before you start? Oh, I cannot hear you. You're at mute right now.
Yeah. Matrix is 1 plus 2 minus 1 equals minus 1 for the top row.
Okay.
Middle row is 1, negative 4, 1,
no,
positive 4.
No. Second row is wrong.
It would be x minus 4y plus z equals 4.
Why 4y? It's just y.
Oh, I didn't see that. Okay. It's just 3 equals 2.
Negative 2. Perfect. As soon as you get one step, let me know what you are doing so that I can check what you are doing.
All right, so we already have 1 as the first top coordinate here, so we're moving to the second row.
Okay.
So we want to make the first coordinate in the second row 0.
Mm-hmm.
So we're going to multiply the entire second row by negative 1.
Not the since you are changing the second row, you will not multiply by second row. You multiply any other row, not the second row. So you're changing second row.
So multiply the first row by negative 1.
Exactly. The row you're changing, you don't multiply by that one if you're adding.
Okay. And then we add the second row to the first row.
Yes.
Right. Okay, so that gives us 0, negative 3, 2, and 5.
Perfect.
Okay. So now we need to get rid of that negative 3. So we're going to take the third row.
No. You're still missing something. Before you go there, you have to make this 0.
Okay, got it. Okay. That's right. I do to work down. Okay, so since we're at 1, 1, -3, 2, we're still gonna, again, we're gonna multiply
Brian,
the
it's
first
negative
row.
2. Brian, it's -2, not 2 at the end.
Oh, okay, sorry, transposition error. Okay, so we're gonna take the first row, again, multiplied by -1, and then we're gonna add it to the third row.
Perfect, yes.
Correct?
Yeah.
Okay, so that gives us 0, -1, -2, -1.
Perfect, yes.
Okay, so now we have to work on the second row to get the middle, to be 1,
Yes.
correct?
Yes.
Okay, so that means we have to multiply the third row by 2.
Okay, third
Sorry, by -2.
Okay, you're saying by -2, yes. Perfect.
By -2. Right?
Yeah.
Okay, so then that makes that 0 still. -2 would be 2, adding that to -3. Wait, does that work? Hold on. But that gets us -1. Hold on.
I want 1.
Yeah. So actually, we have to multiply the row by -4.
Okay, -4 you are saying. Okay, let's multiply by -4 then.
Okay, so -4 gives us 4 there. Plus the -3 is 1. -8 plus 2 is -6. And -1 is 4. 4 plus 5 is 9.
You got the second term wrong. I mean the third term. How did you get 6?
Well, because -2. Oh, sorry. Is it 8?
Yeah. 8, 9, 10.
Negative, yeah, it's 8. Okay.
So the answer will be 10, not 8.
Oh, 10. That's right. Yeah. Okay.
What's the next step?
Oops, hold on, I'm writing this. I ran out of paper. Hold on. Let me just get where I am. 1, 2, -1, -1. And 16, 0, 1. Third row stays the same. 2, -1. Okay. So now the middle term in the bottom row we have to get to be 0.
Yes.
So now we can just add rows 2 and rows 3 together.
Yes. Can we do this after, like, you know,
Right.
because it's already like 15, Brian, we'll do after the classes, okay?
Yeah.
Okay, perfect.
Well, again, I just kind of wanted to do it without help.
Yeah, just
the
do
point.
it and maybe I'll give you the answer, okay? Later, maybe you can find it after the class and I'll give you the answer, final answer, so that you can check. Okay. So now we are going to start with is determinants. Determinants. Let's see here. So if you are given, let's see here, it's like, yeah. If you will be given something like this, okay, you'll be given 4, 1, 0, -9, 3, 4, -3, 8, 1. They say you have to find the determinant of this thing. Find determinant of this thing. How do you find the determinant of this thing is make this straight lines. this bracket will change into straight lines. When they write this straight lines, they actually mean that you are finding determinants, and write whatever was given inside there. If they write like this only, just with straight lines, they're basically asking you to find determinants. This straight lines, 2 straight lines means find determinants. That's how you write it. So in this case, you have 3, 1, row 2, row 3. Okay. You have column 1, column 2, column 3. Pick up any row, any column you want. Pick up any row, any column you want. Usually, I would suggest you to pick up row or column which has maximum zeros. I would suggest you to pick up row and columns which have maximum zeros. So you decide. Anyone tell me which row and column you want to work with. It's up to you. Any row, column. Anyone?
There's only 1 0 in column 3 row.
Okay, it's in column 3 or row 1, whichever you want to do. I say let's deal with column 3. Since he said column 3, let's take column 3 then. Okay, what you're gonna do is write all the 3 terms of column 3 like this: 0, 4, 1 at distance from each other. You're gonna write the numbers of column 3 at distance from each other. It's up to you which one to decide, which one to choose. It's up to you to decide which column to choose or row to choose. He said choose column 3. So all the terms of column 3, 0, 4, 1, I wrote like this. After that, what you're going to do is, you're going to make small box. You're going to make small boxes after that.
Professor, why did you write row 1 kind of like just all mixed around versus the order with that it's in? Or does that even matter?
No, why did I wrote column 3?
For like row 1, how you wrote 0, 4, and 1. Does it matter how we write it out? Because it's 4,
no,
1, 0.
I did not write row 1. I wrote column 1. I wrote column 3.
Oh, okay. Oh, got it. Okay.
Yeah, it's up to you. You can choose row 1 also. You can write 4, 1, 0. It matters. The order matters. But in this case, I'm choosing column 3, so I'm writing like this: 0, 4, 1.
Okay.
Yeah. And then you're gonna make these lines here. And then what you're gonna do is, first is 0, right? You have 0 here. I want you to hide the row and the column which has 0. Hide the row and the column which has 0. This row and this column had 0. I hided that. And whatever is left, I want you to write inside the bracket here. I want you to write inside the bracket here. So you're left with -9, 3, -3, 8. If it's 0, I want you to hide the 0 and hide the column and the row which has 0 and write everything else inside there next to 0. Next thing is 4. I want you to hide the row and the column which has 4 and write everything else there. Write everything else. 4, 1, -3, 8. Right there. 4, 1, -3, 8. Similarly for 1, now you have 1. Hide the row and the column which has 1 and write everything else there. 4, 1, -9, 3. 4, 1, -9, 3. You got this thing. Now another thing to remember is when you have 3 cross 3 matrix, when you have 3 cross 3 in your syllabus, it's basically 3 cross 3 only. You need to, on the side, you need to remember this table. You start with a positive sign. You start with a positive sign and make it alternate. Positive, negative, positive, negative, positive, negative, positive, negative, positive. Start with positive and keep on going. Positive, negative, positive, negative, positive, negative, positive, negative, positive. Make this table on the side for yourself. Now see 0. At this position, what sign I have? Positive. So I put a positive sign in front of 0. 4. 4 is at this position. There is a negative sign. So I'm going to put a negative sign in front of 4. 1 is at this position. I put a positive sign. Anyone so far, any doubt how to do this? You choose any column and row you want. Write the terms. Make the bracket. Hide the row and the column. Whatever is left over, write inside there. And from this box, you put the alternative signs.
So when we're making the table there with the positive and negative signs, they're just always alternating, right?
Yes, always alternating.
Like we just make that like in that order always.
Always, yes. Starting from positive, always this order. Yes. For 3 by 3 matrix. Okay. So next thing what you're going to do is the term with the 0, 1, technically you can write it, but it does not matter. 0. How you're going to do it is, how you're going to do it inside, how you're going to solve is, multiply the first term with its alternative. So multiply negative 9 by 8. It's diagonal element. Multiply the first term with its diagonal element. So multiply negative 9 with 8. Then put a negative sign. Then you're going to put a negative sign yourself. Then second term with its alternate. 3 times negative 3. Again repeat. It's like similarly for the next term. First term with its alternate. So it becomes 4 times 8. Then you're going to put a negative sign yourself. Second negative sign yourself. And then first the second term with its alternate. 1 times negative 3. Similarly the last one. 1. First term with its alternate. You get 4 times 3. Then you're going to put a negative sign yourself. Second term with its alternate. That's it. And then you solve. That's it, all you need. Solve inside the bracket first. Solve inside the bracket. Let's see. Negative 9 times 8. Negative 72. Negative 3 times negative 3. Positive 9. Get negative 4. 8 times 4 is 32. And then this becomes negative 4 plus 1. Do the multiplication. 4 times 3 is 12. This becomes positive 9. Do the multiplication part. Multiply first. These, and these. Multiply first. And I
have a
yeah.
Professor.
Yeah.
How did you get negative 4 and positive 1? Is that because of the table you made on the side?
Yes, because of this thing. See these tables, right? So 0 was at this position, right? So I put a positive sign in front of 0. 4 is here. What's the sign here? At the 4th position, negative. So I put a negative in front.
So it's based off of the original columns.
Yes. Based on the table, yes.
And then the sign inside the parentheses. So like you had negative 9.8 or negative 9 times 8 minus. Where'd you get that minus from? Is it just always
this minus is always there. This minus is always there.
Okay.
So first diagonal multiply, then put a minus sign, and then the second diagonal multiply.
So the table on the side with the plus negative is just for the initial
signs.
Plus,
yes.
Or plus. Got it. Okay.
How do you get the negative 4 and the 32 and negative 4? Because I thought you multiplied them together.
Yeah. So 8 times 4 is 32, right?
Yeah.
And then what is negative 1 times negative 3? Oh, it's negative 3. Sorry. You're correct. It's negative 3. I'm sorry. My calculations. It's negative 3. Correct. And then you solve. Note 0 times anything is 0. So I don't even have to calculate this thing. That's why we choose a row and the column which has maximum zeros. So that you don't even have to calculate this thing. Just start calculating from here. You get negative 4, 32 minus 3, which is 29. And then plus 1, 12 plus 9, which becomes 21. And then you can use your calculator or you can solve whichever way you want. You can, so it is negative 4 times 29. And then you can add 21. Minus 95. That's your answer. That's the determinant of that matrix.
I have a question.
Yeah.
How did you pick, sorry, to go back a little bit. So for like the 0, 4 and 1, how did you, what numbers, how did you determine what numbers to put?
Okay. Basically you try to choose rows and columns. Usually it does not matter which row or column you choose. You can choose this row. You can choose this row, this column. It's up to you which one to choose. I try to choose ones which has maximum zeros. I try to choose row and column which have zeros. Okay. He said he wanted to choose row 3 because this has 0, right? So he chose this one. Yeah. Okay. Why he chose 0 is C, because you don't have to do calculation for the 0 part. You don't have to use calculation for the 0 part because anything multiplied by 0 is 0. You just have to do the calculation for the other two. Are you getting my point, Chanton?
Okay. Yeah, so so for 0, for example, you chose -9, 3, -3, and 8. How did you get those numbers?
Okay. So first it's 0, right?
It's the remaining number.
Yeah, it's 0, right? It's 0. Hide the row and the column which has 0. This column has and this row has 3, right? 0, right? I hide it. And whatever I'm left with, I'm gonna write here. I was left with -9, 3, -3, 8. I wrote it inside. Are you getting my point? It was 0, right? It was 0, right?
Okay, got it. Yeah.
Yeah. I'm going to do one more example.
Yes.
Let's do one more example. You'll get it. Let's do one more example. I'm going to do one more example here.
I have a question on that one.
Yeah.
Okay.
I got positive 35 for the 4 times.
It's -4 times.
So -4 times. So you got 4 times 8, which is 32. And then you got 1 times -3, which is -3. Then you
actually it's +3. My bad. It's gonna be -4 and then 6 35. I'm wrong. It is gonna be 35 plus 21. I'm wrong. So it's gonna be -140 plus 21. I'm sorry, the calculation. I'm sorry. It's gonna be +3. Negative makes it positive. So it's gonna be +3, and 32 plus 3 is 35, and then you got 140 plus 21, which is 931 -119. That should be your answer. Yes, that's the answer. -119. That's your final answer. Caesar, what happened? You were getting completely different answer.
No, yeah, I got that.
You got
I just don't get what we just solved for. Like, I don't get where. I don't know. I don't get what we did.
Oh, okay.
Like,
Listen.
So like 119 is just the determinant of those 9 numbers in that order.
Yes, exactly. That's a determinant. So determinant is basically it tells you like in how fast rate is the number. I mean, like it's how do I explain this? So you were given not equations. You can say it's not the equations. It's basically tells you how fast the pace is increasing for something. Like let me take an example for this thing. How do I explain? It just tells you how fast something is increasing. I'll find an example and I explain you why we are finding the determinants. But the method, you should understand the method. That's one thing. Okay. So let's do one more example. I say you are given 2.
I have a quick question.
Yeah.
Just for at least this problem, can you explain, like maybe in a step format, of why we're choosing the specific like 4 numbers for each like column when we have that column that we choose?
Exactly.
Because I just didn't understand that, like how we chose that.
Okay.
But
Jordan, okay. I want to choose a row or a column. Any row, any column. You choose which one you want to choose.
Column 2.
You want to go with column 2. You're saying you want to go with this one, right?
Yeah.
It's okay to go with that one. It's good. It will still give you the same answer. No matter which row or column you choose, it's going to still give you the same answer. But usually my suggestion is to make your calculations easier. I would suggest you to go with row or column which has maximum zeros.
Okay.
So which one are you going to go with?
I'll probably go with column 3 now.
You are saying column 3. Or I can go with row 2 also, right? This also has 0?
Yes.
Anything. But since you said you are saying it that I want to go with column 3, so I'm going to go with column 3 now. Okay? Since you are saying it. I can go with row.
Because you said there's maximum, go with the one that has maximum zeros.
So. Even row 2 has zeros. If you see row 2 also has zeros, right? I can go with row 2 also.
Oh, okay, yeah. So either row 2 or column 3.
Column 3. A maximum zeros one. It's up to me which one to go. You which one you want to go? Row 2 or column 3?
I'll just stick with column 3.
Okay, let's see column 3. Since you are saying column 3, I'm not taking because I took in previous example column 3. That's not the reason I'm taking column 3. I'm taking because it has a 0 in it. Maximum 0, 1 I'm taking. So what I'm going to write is all the numbers in column 3 I'm going to write here. 7, 0, 1. I'll write all the numbers of the column 3 there. Then I'm going to make a bracket there next to them because I need to add the terms there.
This is the part that I get confused about. So okay. How we choose the numbers. So if you can kind of just go a little more slow.
Yeah, I'll cut slow. Okay. What you're going to do is, let's see 7. First we chose 7, right? First number was 7, right?
Yes.
Which row and which column has 7 number? Which row and which column has 7 number?
Row 1 has it in.
And 7 rows, column 3, right? 3. I'll hide those. I will hide those. I hided them. What am I left with?
Yeah. Okay, so -5, -4, 6, and 3.
That's what I'm going to write here. -5, 6, -4, and 3. In that order only. Okay. Next term is 0, right? Row 2 and column 3 has it. So I'm going to hide my row 2 and column 3.
So thank you for explaining this because it makes it a lot easier.
Yeah. So now what are you left with?
2, 1, -4, and 3.
Perfect. Okay. Let's see the third one. 1. Let's hide the column and the row which has 1.
Yeah. So it's going to be column 3 and row 3.
So what do you get?
2, 1, -5, and 6.
2, 1, -5, and 6. Perfect. You got this thing. Now I have to figure out the signs here. I don't know what the sign are. I need to make the sign table here. How do you make the sign table is, you start with positive and go alternate. Positive, then comes negative, then positive, then negative, then positive, then negative, then positive, then negative, then positive. Start with positive and keep going, alternate signs. That's why it's easier to remember. Okay. Haley, 7 is here, right? 7 is here, right?
Yes.
What's the sign at this, in this table at that position?
I'm sorry, what?
So we are talking about column 3 only. So I'm going to look at column 3 only now. Okay. What's the sign in the first sign in column 3? Positive, right?
Oh, positive.
So I put a positive in front of 7. Okay. Second term was 0 and here was 0. So right in front of 0 I want to put a negative sign.
Oh, okay.
Here it was 1 and here is positive. I put a positive in front of 1.
Of the 1, yeah.
So whichever column you chose, you're going to look at that exact sign. You're going to look at exact that sign and put the signs alternately.
Oh, okay.
Yeah. Once you got this.
Is that like the positive, negative, positive, that little bracket thing? Is that consistent with every single problem?
Exactly. It's consistent with every single problem. You start with positive and alternate.
Okay.
Yeah. Okay. And then what you're going to do is, after this, let's solve. 7. Keep as it is. In the bracket, how do you solve is, take the first term, multiply with its diagonal. So you get -5 times 3. First term with its diagonal, and then you will put a minus sign yourself. This minus sign comes yourself. And then the second term with its diagonal. So 6 times -4. Then again you get -0. Okay. First term with its diagonal, you get 2 times 3 negative. And then second term with its diagonal, -4. And then...
Wait, why are we adding that negative in front of the 6?
This thing, this negative sign?
Oh, okay, because we're still following that, but then also with the same... So I just want to clarify this. So for the column, we're changing the signs based off of that little diagram.
Okay.
About the signs. And then the numbers that are within the parentheses or the bracket, we're changing those signs as well, depending on where they were.
Yeah, exactly. But you know, the thing is, they are, but you have to multiply. You're not changing signs. What you do is take the first term, multiply with its diagonal. So it becomes negative 5 times 3. You write it there. Then you will put a minus sign yourself. You will always put a minus sign yourself. Okay? And then second term with its diagonal. 6 times negative 4. You do for all of them. In this case, it becomes 2 times 6, then negative sign yourself, then 1 times negative 5. And then solve. Negative 5 times 3 is negative 15, negative 6, negative 24 plus 24. Get this thing. 0, 1 you don't have to calculate. That's why we choose the 0, 1, because you don't have to calculate for that one. Anything multiplied by 0 is 0. This whole thing is 0. So you don't have to calculate. Let's calculate the last one. 12 plus 5. So you get 7 times 9, okay, plus 1 times 17. 63 plus 17, you get 80 as your answer. Any doubt with determinants?
I get how to answer the determinant. I just don't know what we're determining.
Yeah, so let me look at an example. Maybe I can tell you. I'll just kind of figure out how to explain you what determinants are, why we're doing it. But yeah, so while I'll do that, I want everyone to find the determinant of this thing. By that time I'll find out what to do with that thing. So I want you to find determinant for 2, negative 1, 3, negative 4, 0, 0, 2, 5, 4. Find the determinant for this thing right now.
For the first equation that we were working on, where it says negative 5 times 3 minus 6 times negative 4, why did we turn that into a positive?
Because negative 6 times negative 4 is positive. Negative makes it positive.
Oh, okay, so that's negative 6 times negative 4?
Yeah. Here, if you're having problem, what I would suggest you is, rather than doing the calculation here, in the calculator, enter this whole thing directly. Enter this whole thing directly in the calculator. That will give you an answer too.
Professor, what's that bottom right number? Is that a 9?
4, 4, 4.
It's a 4?
It's a 4.
So it's 304 for row 3?
Yes, 304.
Thank you. Also, real quick, is that, it goes 2, is that minus 4 or minus 7?
4, 4. Anyone who got an answer can tell me what answer they got.
Negative
I got
68.
Negative 68.
Negative 68. People say negative 68. Anyone who got different answer?
I got 76.
Positive or negative?
Positive.
Positive 76. Anyone else? Any other answer?
I got negative 76.
Negative 76. Anyone, any other answer? Let's see, who got negative 68?
I did, Brian.
Brian. Okay, Brian. Can you tell me which row or column did you choose?
Yeah, I chose column 2 because it has the most zeros.
Perfect. So you wrote 4, 0, 0. And what did you write inside 4?
Negative 4, 0, 0, right?
Yes, negative 4, yes. So what does it become? What do you write inside here?
So the top rows there is negative 1 and 5. Bottom row is 3 and 4.
Perfect. I don't have to worry about 0, 0 because they're not even calculated. I just have to worry about this. But I need to see the sign table. Plus, minus, plus, minus, plus, minus, plus, minus, plus. What's the sign in front of negative 4?
Negative.
So it makes
changes
it
to a positive 4.
I just need to calculate this now. I don't have to worry about the 0 ones. Let's see. 4 remains as it is. First term with its diagonal, negative 1 times 4. Then you put a minus sign yourself. Second term with its diagonal, 5 times 3. You get 4, negative 4, negative 15. Which is 4, negative 19. Which is negative 76.
Okay, I made a mistake. I transposed 5 instead of 4, so that's why I screwed up.
And for people who got 76 also, that's wrong. Anyone who did not understand how I got negative 76, correct answer is negative 76, not 76. Any questions, anyone with determinants? And why is determinants found is, so if you take higher mathematics, there is something known as inverse. Okay, if you are not interested in this, why we find determinants, don't listen to this thing. It's going to confuse you a little bit more. But
I have, sorry, quick question. How, I thought it was negative 4. Did we convert it to positive 4 somewhere?
Yes, we convert it into this thing. The reason is when you make the table that plus minus plus minus plus minus 1, right, Haley? 4 was at this position. Negative 4 was at this position.
Oh, like in the middle?
In the middle, right? So that's why I put a negative sign extra in front of it.
Oh, okay.
And then 2 negative makes it positive.
Oh, okay.
Yeah.
Cool. Thank you.
So I won't suggest you to hear this unless you want to know why we find determinants. There is something known as inverse of matrix. Inverse of matrix, which is not in your syllabus, but if you take college algebra, pre-cal after this, where you will need this determinant specifically to find, it is one of the steps to find the inverse of a matrix. It's just that in your course they want you to learn this method determinants so that in future you know already how to find the determinants. Also, what are determinants? It helps you find the rate of change of area or volume. How much rate, how much my area and the volume is changing, how much faster or slower my area and volume is changing when I'm doing the linear transformations. When linear transformations, you don't have to write, these are being performed. That's the reason we do it. It tells me how much rate my area and volume is changing when I'm doing my linear transformations. So these are the 2 reasons we find the matrices. Don't get confused. Determinants. Don't get confused, but these are the 2 basic reasons. When you take higher mathematics, you will need determinants in inverse. You cannot find inverse if you don't know your determinants. Yeah. Any other questions? Anyone with determinant so far? Okay. The last thing we're gonna do today is Cramer's rule. Very easy. If you know how to find determinants, Cramer rules is very easy. How do you do it? The Cramer rules is, so far we have done various methods to solve system of equations. We did substitution method, right? We did elimination method. Okay. We did matrices method. These are the three methods we did to solve an equation and find the value of x, y and z. I again repeat. Three methods which we did already: elimination, substitution and matrices. We did these three methods to find the value of x, y and z. The next method is Cramer's rule. We will be using Cramer's rule to find the value of x, y and z. Okay, so you will be given three equations. Suppose you are given a1x plus so you can say a1x plus b1y plus c1z is equal to d1. Suppose this is my first equation and my second equation is this thing, and my third equation is,
what is the name of the rule? What does that say?
Cramer's. Cramers. Cramer's.
Cramer's.
Yes, Cramer's rule.
Oh, okay. Yeah, Cramer's rule. Yeah.
So you have this thing. These are the three equations, okay, given to you. I say you have to use Cramer's rule to solve this. First, you will find your x. How will you find your x value? Is dx divided by d, where d is the determinant. Y is dy divided by d, and z is dz divided by d. You will be like, what is this dx, dy, dz and d? What is these values? Okay. So basically your d is what? D is gonna be what is, basically you're gonna make a matrix out of the coefficients of x, y, z. X, y, z. Then second equation x, y, z. Third equation x, y, z. And find the determinant of that thing. That will be your d. You know what's gonna be a dx? What's gonna be your dx? Dx is gonna be, so note, this was my x, this was my y and z, right? I was writing the coefficient of x, coefficient of y, coefficient of z, coefficient of x, coefficient of y, coefficient of z, coefficient of x, coefficient of y, coefficient of z. Note, now I'm finding dx. If I'm finding dx, my x row will change, this whole x row will change. This x row will change. Everything else will remain as it is. B1, B2, B3, C1, C2, C3. And you know what is my x row gonna change to? The constants here. D1, D2 and D3. They're gonna change to D1, D2 and D3. And then you're gonna find the determinant of dx. Similarly, you're gonna find dy. In dy, you're gonna see the original determinant d. Now my y row is gonna change, y column will change, everything else will remain the same, and y column will change to the constants on the other side, d1, d2 and d3. Similarly, dz, that means my z column is gonna change. In the original one, my first two will remain as it is, a1, a2, a3, b1, b2 and b3, and the third column will change to the constants, b2 and b3. That's it. Once you know the determinants of this and this, plug in the formula and you will find your answer. This is one of the very easiest methods to find the value of x, y and z. This is one of the very, very easiest methods to find the value of x, y and z. So let's do an example. They say x plus 2y minus z is equal to -4. And they say x plus 4y minus 2z is equal to -6. 2x plus 3y plus z is equal to 3. This is given to you. They wanted to use Cramer's rule. For Cramer's rule, I need d, I need dx, dy and dz. If I know all these, I can find the value of x, y and z. Okay, let's see what's my D first. Let's see my D first. Coefficient of x is 1. Coefficient of y in the first equation is 2. Coefficient of z is -1. Make sure they are in standard form. X, y, z is equal to constant. X, y, z is equal to constant. X, y, z is equal to constant. Then you write coefficient of x first, then y, and then z. You don't have to write equal to in this case. Similarly for second one, coefficient of x, coefficient of y, coefficient of z. Coefficient of x, coefficient of y, coefficient of z. It's up to you which row, which column. I said, oh, to choose the row or the column which has maximum zeros. This one does not have zeros. So it's up to you which row column to choose. It's up to you. I choose column which has next after 0 comes 1. I will choose row or column which has maximum 1s. I'll go with column 1. Calculate the determinant. 1, 1, 2. Make boxes, make boxes, make boxes. 1. Hide column. You will get 4, -2, 3, 1. Hide the row and the column which has 1. You get this thing. Then hide the other one. You get 2, -1, 3, 1. So you get 2, -1, 3, 1. Then hide the 2. You get 2, -1, 4, -2. -1, 4, -2. Let's see the sign. Positive, negative, positive, negative, positive, negative, positive, negative, positive. Since I consider C1, I'm going to put first positive, then negative, then positive. Then solve. You get 1. 4 times 1 is 4 minus 3 times -2 is -6. -1. 2 times 1 is 2 minus 3 times -1 is -3. Plus 2. 2 times -2 is -4, then minus -1 times 4 is -4. So you get 1, 4 plus 6, 10, -1, 3.
Why did we pick column 1?
It's up to you which one to take. I chose column 1.
Oh, okay.
Yeah, it's up to you which one to take.
Okay.
Then you get -4, and then this becomes 0. So basically you get 10 minus 5, which is 5. You found your D as 5. Do it yourself. D you can find yourself. Don't see this method. Basically we did determinants already. I want you to find D yourself. Use your own formula. You don't have to use C1. Use any row, any column you want and find the value of D. You will get 5. And then we will find dx. We will find dx. For dx, what in my D? This was my D, right? Okay. This was my D here. First one will always, this was my x, y, z. Remember, this was coming from x, this was coming from y, this was coming from z. So first column tells my x, this tells my y, this tells my z. Now since I'm finding dx, since I'm finding my dx, the x column will change. Everything else will remain as it is. And x column will change to the constants on the other side. It will change to this thing. So my dx will become -4, -6, 3 because my x column is going to change now and everything else remains the same. 2, 4, 3, -1, -2, 1. Use determinants to find this thing. I want everyone to use determinants. You know how we did. We did already. This is practice. We have already done. Find the determinant of d to the dx.
Can you show us again how you got -4, -6, and 3 for the first column?
This was your original matrix, right? This was your original determinant matrix, right? So now I'm going to find my dx, right? dx. So note first, okay, when you were writing the coefficients here, you wrote the coefficient of x, then y, then z, right, Caesar? Then again
right.
x, y, z, x, y, z, right? So technically my first column is giving me x, right?
Right.
My second is y and third is z, right? Now since I'm finding dx, right? What I'm going to do is only my x column will change. Only my x column will change. If you're finding dx, x column will change. If you're finding dy, y column will change. If you're finding dz, z column will change. But since I'm finding dx, my x column will change. To what? To the constants on the other side. So dx will be -4, -6, 3 here, and everything else will remain the same.
Oh, okay.
Okay.
Can you leave it there real quick?
Yeah.
I never wrote down the example.
Okay. Yeah. You can note down this. I want someone to find the value of dx. What did you get dx as? Find the determinant of dx.
But so I'm confused. Do we take the individual numbers that we got from that and now plug them into D1, D2, D3?
D1, D2, D3. You mean dx, dy, dz?
I don't know.
No. What are you saying, Brian? Can you repeat again?
Okay, so I solved for column 1.
Okay.
I got 10, -6, and 0. Do I not add those together to get a 4?
10, -6, 0. Oh, you get -4, -6. Oh, wait, where are you getting 10? For this thing, for dx? You're getting for dx as 10?
I'm still in the first part of the formula.
Okay, still on the first part of the formula. So what I did
So
is...
I'm solving for column 1, which is 1, 1, 2.
Okay. And then you got here 10, right?
Yeah.
And did you get here 5? -1, 5?
For where I got -6. The next one.
How did you get?
Oh no, yeah. I'm sorry. I wrote it wrong. It is a 5. Yeah. Negative. I got -5.
And what about the last one?
0.
Yeah. So you got 10 minus 5, which is
5.
5. So you get 5 here. How do you find dx is in the original D? In the original D, you will keep the y column and z column as it is. But you're going to change your x column to -4, -6, and 3. The constants on the other side. So that's your dx.
I'm really lost in that. You talk very quickly.
Okay, see here. This was my original matrix, right? Okay, I need to find dx, right? Since I'm finding my dx, no, Brian, here. When I was writing my matrix, remember this was coefficient from x, this was from y, and this was from z, right? Similarly here, this one was from x, y, and z, x, y, and z, right?
Wait, hold on.
So,
are you talking about the first column is x, the second column is y, the third column is z? Is that what you're talking about?
Yes. You know why I'm calling them x, y, and z? You know that?
Yeah, I mean, I get it before, but like you when you explain it, you talk so quickly. Sometimes it's hard to write and slowly follow what you're saying.
Okay, I'll go slowly. Okay, so this is my x term, right? This is my x line, right?
Correct.
Okay. Now, since I'm finding my dx, so my x row column is gonna change. Everything will remain the same. See, everything else remains the same. Okay. And what is x column gonna change to? X column will change to the coefficients on the other side. So of the equation, this was my original equations. And whatever coefficients I have there on the other side of the equal to sign, these constants, this will become my x now. This will become my x now.
So yeah, maybe I'm just confused as to where you got that original equation. The original equation I thought was 1, 1, 2, 2, 4, 3, -1, -2, -1. So now we're substituting
No, there
what was in
original
the first
equations.
original equation, -4, -6, -3 for the x column?
Yes, yes.
Okay.
So these were the original equations. Kramer rule is basically helping me find the value of x, y and z which will satisfy all the three equations.
Okay. All right. Now I think I have a relatively better understanding.
Anyone who got the value of dx? Who solved and find the value of dx?
I got -10.
Perfect. Yes, it is -10. When you solve the determinant for dx, you will get -10. Similarly, find for the dy. How do you find for the dy is, see your original d. See your original d. For dy, you're going to see your original d. Since I'm finding dy, my x and z column will remain as it is. Only my y column is going to change. And what is it going to change to? It's going to change to the same constants on the other side. Constants on the other side. -4, -6, 3. So put there. -4, -6, 3. And solve. Find the value of dy. Find the value of dz also. For dz again, my x and y of the original d will remain the same. Note my x and y of original d, not the upper one, will remain the same. And only the z column is going to change to the, here, constants. -4, -6, 3. Solve these, find the determinants. dy and dz. Find the value of dy and dz. If you get your answer, please let me know. But you can find the value of dy and dz. Basically, in this case, when you solve, you will get dy as 5. Make sure you try this. And dz you will get as 20. When you solve these determinants, these are the values you're going to get. X is basically dx divided by d. Y value you will find by dividing dy by d. And z you will find by dividing dz by d. And dx is -10. So you divide -10 and d we found as 5, which is -2. So you find your x value as -2. Similarly, y you will find by dy is 5 and d also you found as 5. So y comes out to be 1. dz is 20. 20 divided by 5, you get z as 4. So that's your value. Make sure you know how to use it. This is one of the Kramer's rule, is the easiest way of doing and solving equations, and where you can have least calculation mistakes. So you should know how to use this Kramer rule also. When you get a problem on Kramer's rule, at least it will be worth like 5 to 7 points.
Professor?
Yeah.
Sir, I don't know if you're reading the chat, but there's people who are leaving because they have to go to work and we're going over our class time. So I just want to let you know.
Yeah, okay. So I have everyone's attendance, except I'm going to take the people's name whose attendance I don't have is Dylan Robert, Joshua Jess, and Julian Robert, Richie, I don't have, and then Reese Alexander, and then Joshua Hernandez, and then Kenya. These are the people whose attendance I don't have. Other than that, everyone, they can go. And if you have doubts, you can always stay back right now. I'm going to help. Thanks, guys. See you on Monday.
I'm here.
Josh.
I need help.
Just a second.
Thanks, Professor.
Thanks, guys. Take care. Okay, Joshua, okay.
I'm not sure if you said my name for the attendance, but I'm here.
Brett, just a second. Brett, I want to see. What's your last name?
Kepperling with a K.
Okay, let's see. With a K. Right. Okay, yes, I said your name. Yes, you have it.
Alrighty, thank you.
Yeah, perfect. Take care. Have a nice day.
Yeah, you too. Thank you.
Bye. If you need help, stay back. I'll help you.